All right, so here it is spinning. We've got the gyroscope spinning. Let's get, whoa! Let's get it spinning good and fast, right? So as far as precession goes, right? This thing, the first thing is you want it this anti-clockwise, right? So that our L vector, the angular momentum vector, points away from that, right? Okay. And then as far as, which way it's going to precess, well, it's pivoting about this point. So R is this way, right? The force acting on it is down. And so if you take your hand like this, right? R is that way, force is down. My thumb of my right hand is pointing this way. And sure enough, if I let go of this thing, indeed it goes that way, right? It's always going in the direction that we predict. Okay? Now, I also explain to the kids, because it's like, okay, that's weird, right? We're doing vectors in kind of a weird way, right? Okay, but that's not why it does that, right? And I got this from the Cartoon Guide to Physics. There's good stuff in there. I always read this section in there. So if you look at this little bit of red stuff, right? When it goes from here to here in my hand, the net effect of gravity is to push the top of the wheel out, right? As this thing goes down, the top of the wheel is going out, and so as a particle goes from here to here, it's going to gain a momentum that way, like a linear momentum, right? So this part of the wheel is going to go that way, right? Okay, and as it goes from here to here, across the bottom, the net effect of gravity is, well, it's pushing this part in. So as it goes from across the bottom, it's going to gain a velocity toward me, right? So if this side of the wheel is going that way, and this side of the wheel is always coming toward me, the net effect is for this wheel to just rotate the way that we predicted using the vector cross product, right? Okay, so okay, I can just hold this end, and sure enough, that edge of that thing, the net effect is that this whole thing is just rotating anti-clockwise, right?